Welcome to Circuits Analytica. In this video, we will discuss behavioral style of modeling in Verilog HDL. Following two statements are used primarily to model the behavior of a design in Verilog HDL. The first one is initial statements and the second one is always statements. A module may contain arbitrary number of initial or always statements. These statements execute concurrently with respect to each other, and order of these statements are not important. Initial statement. An initial statement executes only once. It begins its execution at the beginning of the simulation time, that is at t is equal to 0. The syntax of an initial statement is initial inside square brackets timing control, then procedural statements. Here the timing control part is optional, that's why it is inserted in square brackets. Always statement. Compared to an initial statement, an always statement executes repeatedly. Similar to initial statement, an always statement also begins execution at time t is equal to 0. The syntax for an always statement is always inside bracket timing control procedural statement. Here the timing control part is optional, that is why it's inserted in square brackets. If you analyze these two statements, initial and always, you will find that syntax of these two statements are similar. Procedural statement. A procedural statement is one of the following: procedural assignment, which can be blocking or non-blocking, procedural continuous assignments, conditional statements, case statements, loop statements, wait statements, and disable statement. Timing control. A timing control is one of the following: delay control, that is wait for certain time, event control, that is wait for an event to occur. The square bracket indicates that timing control part is optional in both initial and always statement. For example, reg q. Initial #5 q is equal to 1-bit binary of value 0 semicolon. Reg z. Initial z is equal to 1-bit binary of value 1 semicolon. So here in the example, in the first statement reg q semicolon, initial #5 q is equal to 1-bit binary of value 0 is an example for timing control. Here a delay of value 5 unit is inserted, while in the second initial statement the timing control part is missing. Delay control. A delay control is of the form #delay value space procedural statement semicolon. A delay control value basically means wait for delay before executing the statement. For example, #2 space q is equal to 1-bit binary of value 0. In the previous example, Q is assigned a value of 0 only after waiting for 2 time units. Event control. In an event control type of timing control, a statement executes based on some events. Basically, there are two types of event controls: edge-triggered event control methodology and level-sensitive event control methodology. Edge-triggered event control means triggering an event after occurrence of an event on a signal. For example, always at pause edge Q is equal to D. In this statement, the event is an occurrence of positive edge. So if there is a positive edge of clock, then Q is assigned as D. In level-sensitive event control, the procedural statement is delayed until a condition becomes true. For example, wait inside bracket En space D out is equal to D in semicolon. This means that wait until enable is equal to 1. If enable is equal to 1, then D out is equal to D in. If statement. The syntax of an if statement is if condition 1, procedural statement 1, else if condition 2, procedural statement 2, else procedural statement 3, semicolon. So if condition 1 is executed to be 1 or true, then procedural statement 1 is executed. If condition 1 is false and if condition 2 is true, then procedural statement 2 is executed. Else, if condition 2 is also false, then procedural statement 3 is executed. So this is the meaning of this if statement. So if condition 1 is evaluated to be 1 or true, procedural statement 1 is executed. If an else statement is present, then next statement is executed based on the condition. Else, the if statement is terminated. Another important behavioral statement is case statement. A case statement is a multi-way conditional branch. Syntax of a case statement is as follows: case expression, case item expression 1, various procedural statements, case item expression 2, procedural statements for that case statement. Finally, case item expression N, procedural statements for that case statement, and default procedural statements if none of the cases are satisfied. Then finally, the keyword N case denotes the end of the case statement blocks. Let us consider an example. Case yes. 1-bit binary of value 0, z is equal to A. 1-bit binary of value 1, z is equal to B. Default, z is equal to 1-bit binary of value 0. Finally, n case, which indicates ending of the case block. So meaning of this block is, if S is equal to binary 0, then output Z is assigned as A. If S is equal to binary 1, then Z is assigned as B, and default value of the output port Z is equal to binary 0. This is the example for a case statement which can be included in the body of the module for a 2:1 multiplexer. So the if statement and the case statements are the two most important behavioral statements in Verilog HDL. Thanks for watching Circuits Analytica. Enjoy learning.